Okay, we're in section 112 now. Again, contents, examples, exercises. My name is Ron Bannon. This is a draft version of my adaptation of Webster Wells' Advanced Course in Algebra dating back to 1904. The PDF document that you're looking at is being made available to the PRISM Mathematics Project participants only. So students and teachers may want copies of this, and if you do, please reach out to me and I'll let you know what's going to get published. All right? My name is Bannon. My email address is also Bannon, which is B as in boy, the @ symbol, NNON.US. All right? All right, so this section over here is, he doesn't mention it, but it's summation of series by separation into partial fractions. They're actually telescopic series, all right? So I'm going to, go through the examples the way I'd like to explain it. But again, you could look at Wells's work and say, what's going on over there. Now, if I'm doing this one over here, I do want to point out, looking at the series, if you were to just simply say, I'm going to add the terms together and see what happens, not a good idea. Really what I'm trying to do is I'm trying to, try to get some kind of pattern over here. And I want to get, there will be a term over here. I'll eventually get to a term. And what's a term going to look like? I'm going to say it looks like 1 on top, right? And then looking at the bottom, I'm going to say it looks like a product of two numbers that differ by 1, all right? Now, I'm going to say n plus 1 and n plus 2, with the understanding that the first term is a1. Now, I want to see if that makes sense. Now, what I'm saying, if this is the nth term, well, if n is 1, what do I get? I get 2 times 3. It works out beautifully. And this would be a2, and this would be a3. All right? So what I'm going to claim over here, I got the nth term down. Give me 1 second. And what I got to do is, I'm going to split that nth term into 2 parts. Before I do that, though, I want to point out we are going to sum together the terms n equals 1. Let me write this over here for you. One over n plus 1, n plus 2. And we're going to go up to some arbitrary n. All right? That's what we're doing. We're summing the terms together. Now, certainly, I want to match my notes here, so I'm going to change the letters on it. Let me just erase this over here. So I'm going to say I equals 1 up to n, and this is going to be I. If you were to write that down, let me write that down for you. It would be, the first term would be 1 over 2 times 3. The next term would be 1 over 3 times 4. The next term would be 1 over 4 times 5. Boy, that's an easy pattern. Yada, yada, yada. And where would I stop? I'd stop here. 1 over n plus 1, n plus 2. And we're going to call this the nth partial sum. All right? Again, I got a lot of stuff down here. And certainly what I'm looking at, I'm going to break the nth term and put this over here. I'll remind you what we did in the past. It was a long time ago. Maybe you can't remember. Into 2 terms with linear factors. That's going to be b, right? What did we do last time? I guess we multiplied both sides with the LCD, right? 1 equals a, n plus 2 plus b, n plus 1. And then what we do, we picked easy numbers, right? So I'd say n equals minus 1 is an easy number. What would you get? 1. That's never going to change. And then you just get a. So now I know a is 1. And then I would pick n equals minus 2. Well, the left side's always 1. And what do you get there? You just get minus b. So what's the b? The b is minus 1. Let me get my eraser out. And I'll write that down. So someone says, is that in the notes? It is. Let me tell you where that is. It's right here. We got the AN down. Whoops, I keep doing that, I know that. I got the AN down. I split it. We just did that. I'm going to point out where that is, right up there. And this is the AN. We got this part over here. I wrote out SN. That's right here. That's this business right here. I wrote that down. All right? And what I'm going to claim over here is that, you know, I'm going to look at this, this splitting of the problem. And I'm going to write the terms down now. All right? Now, as I do that, someone says, why would you do that? I think there's a pattern to it. So if you were to write down SN, I'm going to write the first term down. And the first term is this one over here. Right? So let me write that down for you. What are you going to get? N is 1, right? The first term, A1. So what are you going to get? 1. And 1 plus 1 is 2. Then you get minus 1. Again, the N is 1, so you get 1 over 3. What's the next term going to be? Well, I'm going to 2 now, so it's going to be 1/3 plus 1. I'm sorry, I made a mistake there. Minus 1/4. What's the next term going to be? Well, if I look at it, it would be 1/4 minus 1/5. And then it's going to be yada, yada, yada until you get that last term. What's the last term going to be? Well, let's write it down. It's going to be 1 over n plus 1 minus 1 over n plus 2. All right? Now, some students like to write this down in columns. I'll put this down for you. It will be 1/2 minus 1/3. The next term would be 1/3 minus 1/4. The next term would be 1/4 minus 1/5. And I'm going to say yada, yada, yada until we get to the end. And the end would be what? Let's write that down. It would be 1 over n plus 1 minus 1 over n plus 2. All right? And again, some students like to write them this way over here. And someone says, why would you do that? Well, if I'm doing that, I'm noticing something immediately. I'm noticing that these things are going to be canceling off. So I'm hoping that you realize that minus 1/5, there would be a 1/5 there to cancel off. Now, before I do that, I want to write down the term before the last term. And what would that be? Well, I got to go backwards, right? And it would be 1 over n minus 1 over n plus 1. And I'm hoping you're realizing that you could actually go backwards in this too. What's going to happen over here? This would cancel off. Let me get my red ink out again. This would cancel off. This would cancel off. You realize a lot of cancellations. All right, so what would I be left with? Let's write this down. So Sn, after all those cancellations, and it's called the nth partial sum, what would I be left with? 1/2. I'm looking around for anything left. I see the 1/2, and then I'm left with this guy in the end. And that's minus 1 over n plus 2. All right? Let me show you where that is in the notes. And again, we're kind of searching around, and I see that right here. Now, what they want to do, I'll tell you what they want to do. They want to get the infinite sum. So really what they're looking for is they're looking at the limit when the n goes towards infinity of the sum Sn. Well, what's that going to be? That's going to be the limit as n goes towards infinity. N's an integer, by the way. 1/2 minus 1 over n plus 2. Well, I hope you realize looking at that something really nice happens with that. When n gets large, this term goes to 0 really quick. So what are you left off with? You just left off with 1/2. And that's the infinite sum. So what are we claiming over here? That the sum, the infinite sum over here, actually turns out to be 1/2. Let me write that down for your notation. So we're saying the sum I equals 1, let me close it out, to infinity of this over here, 1 over I plus 1, I plus 2, in the end is going to equal 1/2. Did I sum together an infinite number of terms? No. I kind of looked around for a partial sum, saw a pattern, and got a pretty good thing going on over here. All right, let's put the next one down. As I do it, I'm looking for this term over here. This is A1. This is A2. And this is A3. Let's write down AN. And look at it. Looks like N. And let's see, 3 to 4. Looks like it goes up by 2, right? So I'm going to say N plus 2. I'm going to check it and see if that's true. And if I start at 1, I get 1, 3. 2 would give me 2, 4. 3 would give me, yeah, it looks beautiful. So what I'm going to do, I'll break it into parts. All right, so let's write this down. I'll put A over N plus B over N plus 2. Multiply both sides by the LCD. Don't be discouraged. This is going to give me 1, A, N plus 2, plus B times N. I would probably choose N to be 0. What do you get? 1, 2A. So what's A? A is 1/2. Let me get my eraser out. I'll put the 1/2 here. Oh, gee, we got to get the B now, right? So what am I going to do for the B? I guess I'll take N to be minus 2, right? On the left side, you get 1. On the right side, you get minus 2B. What's B? B would be minus 1/2. I'll write that down for you. I'm going to write this a little differently. I'm going to write 1/2 times 1 over N minus 1 over N plus 2. All right? So I'm ready to write a sum down now, and I'll put out what I mean by that. I'm going to write the sum down. The sum, I'm going to use the I, equals 1. This is going to be the nth partial sum, and you're going to get 1/2 times 1 over N minus 1 over N plus 2. All right, I'm going to keep writing it down. It's 1/2. I'm pulling it out. The sum, I equals 1 to infinity, 1 over N minus 1 over N plus 2. All right, let's keep going. I'm going to start writing this down. I'm going to write it in a column. Let me put it aside for you. Now, again, I can't, I'm not going to forget this guy. But all I'm working on is this over here. And I'm going to write it down for you. All right? And I put it on the side for you. So I'll start with 1. You get 1 over 1 minus 1 over 2. I'm sorry, 1 over 3. What am I saying? What's the next one going to be? 1 over 2 minus 1 over 4. All right, what's the next one going to be? 1 over 3 minus 1 over 5. Well, you know what? I definitely see something going on here. I just want to get to the end. 1 over N minus 1 over N plus 2. And I'm gonna kind of, and by the way, we're adding these things together. All right? We're adding them together. So I think I'm going to just start writing it down for you. So again, I'm going to concentrate on one thing at a time. Whoops, sorry about it. I didn't mean to do that. I'm going to concentrate on this part here first, and then I'll concentrate on this part next. Let's write it down. All right, it's going to be a lot of work, though. So what do you get? 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 plus yada, 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 up to 1 over N. And then I'll write this guy down. What's it going to be? Minus 1/3 minus 1/4. I think you get the idea. Minus 1/5, yada, 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 minus 1 over N, minus 1 over N plus 1, minus 1 over N plus 2. All right? So someone says, what happens there? A lot of cancellations. This cancels, this cancels, this cancels, everything in the middle cancels, this cancels. And what are you left off with? And I'll write it down for you. You're left off with 1 plus 1/2 minus 1 over N plus 1 minus 1 over N plus 2. And what's this? Sn. It's the nth partial sum. Oops, I forgot. There's a half in front of that. I just did this. I forgot the half. Let me put that in for you. Get my eraser out. And I'll write that down for you. So Sn, yes, I know I'm writing over my work, is 1/2 times this sum. All right, I want to point out where this is. And I just want to outline it for you. Got this. And I got this over here. Let's make sure I got the right thing down. 1/2, 1 over 1 is 1, 1/2. Yeah, I got it. Then what do? The limit as n goes to infinity, which is fairly easy. I'll tell you why. As n goes to infinity, this term and this term disappears. So what he left off with? You left off with something pretty simple. Let me write that down for you. The limit when n goes to infinity of Sn turns out to be 1/2, 1 plus 1/2. Again, those two last terms disappear. That's going to be 1/2. 1 plus 1/2 is going to be 3/2. And what do you get over there? 3/4. Exactly what they're saying it is. All right? So I'm going to say, we did some telescoping series there. All right, what are you going to do now? You got to get busy. You got to do this exercise business over here. There's a lot of, I shouldn't say a lot, I don't know if there's a lot. Problem number 1, I do the work for you. Problem number 2, I do the work for you. Problem number 3, it all has to do with partial fractions and telescoping series. 5, 6, 7, wow, a lot of problems. 8, they're doable though. You also may want to take a look at SAGE. What's SAGE? Computer Algebra System, or CAS for short. It's free or open source. That's the website. You can download it, interact web application. There's some code if you want to play around with it. Here's the deal though. I'm not looking for you to play around with code unless you want to. Really looking for you to do Webster Wells' course. So what are we doing over here? If you see any errors or any kind of like things that are confusing to you, please reach out to me. My email address is Bannon. That's B as in boy, the @ symbol, nnon.us. Please, if you see errors, reach out to me. There's plenty of problems for you to work on now, and they're really going to follow the same exact pattern, right? Do I put all the work down? No, but I put enough work down that might be able to get you through the problems. I always put a final answer down for you, though, so make sure you're aware of that. There are final answers for all these questions over here. Please work the exercises. Again, if you need to reach out to me, saying there's an error somewhere, and I'm not saying there's not. I just spent a lot of time doing this. I'm not saying I don't make errors. I do. Sometimes I'm spacing out a lot. Please get in touch with me. Thank you so much for paying attention.